We are looking at another example of an EOG-like problem. So I want you to think about what you learned this year that applies to this problem and will help you to solve it. Let's go ahead and begin reading. I'm going to grab the hand tool and move this over so that I have enough room to show my work over on the side. All right, below the heart rates of an infant, a 12-year-old and a 2-year-old are listed in different ways. All right, so we have heart rates, they're being listed. Here's the first one. In 5 minutes, an infant's heart beats 650 times. A 12-year-old's heart rate is represented by the equation y equals 70x. So there's our equation. And then the table represents the heart rate of a 2-year-old. So minutes and beats. Try to make sense of this. So in 3.5 minutes, the 2-year-old's heart beats 315 times. All right, if you understand the table, we'll move on to this part. Rank the 3 children by fastest heart rate to slowest heart rate. Then select the answer choice that lists the children in order from fastest heart rate to slowest heart rate. The big clue for me is this word rate. When I see rate, I think, all right, I'm finding a unit rate. What do I know about unit rate? And I think back. I know another name for unit rate is constant of proportionality. I know the unit rate formula is K equals Y over X because K is the letter that represents unit rate. So I know all that information. So what I'm going to do is I'm just going to start by looking at the unit rate for the infant. So the infant color that I'll use is orange. So I'm just going to box the infant information in an orange. And then I'm going to record the unit rate formula. K equals Y divided by X. Now, the infant's information is in story problem form. It's just a sentence. They don't really tell us which is X and which is Y. So we need to use our reasoning to think about what makes more sense. So would it make more sense to put minutes in the numerator and beats in the denominator? So think about it, minutes per beats. Or does this sound more familiar to you? Beats per minute. So beats in the numerator and minutes in the denominator. Hopefully beats per minute sounds more familiar to you because that's normally how we would measure heart rate. If you really aren't sure, another clue that you can use is you could look at the table or if there's a graph and it will tell you which is X and Y in the table or in the graph. So for example, let me choose a different color so that I don't use the same color for infants and for 2-year-olds. For the 2-year-old, we'll use blue. So in the table, X is minutes and beats is Y. So if we were unsure, by looking at this, we've confirmed that the beats is Y. So we should be putting beats up here. So I'm going to go back to the color I'm using for the infant, and I'm going to actually type the beats in the numerator. So the infant's heart beats 650 times. So 650 beats, that goes in the numerator. And then I use per for the fraction bar. And then in the denominator, it's going to be that the denominator is X, so it should be minutes. So it will be that 5 minutes. And then I'll draw a fraction bar in between. Now this is a rate. It's not a unit rate until we divide. So let's think about this. I'm going to think about 65 divided by 5. Well, I know that 60 divided by 5 is 12. Well, 65 is 1 more 5 over 60. So if 60 divided by 5 is 12, 65 divided by 5 is 13. And if 65 divided by 5 is 13, then 650 divided by 5 is 130. So 130 beats per minute. And I need to label this. This is the infant's heart rate. The infant's heart rate is 130 beats per minute. You could have also used long division instead of the reasoning that I used. All right, we move on to the next example, and I'll use a different color. A 12-year-old's heart rate, oh, I need to go to the scribble, sorry. A 12-year-old's heart rate is represented by the equation y equals 70x. So in this example, we have an equation. Remember, a proportional equation looks like this, y equals kx. y equals kx, where k is the unit rate. So this number that is being multiplied by the x is the unit rate. So let's look at what number is being multiplied by the x. Well, the 70 is being multiplied by the x. So our k, our unit rate is 70. So that means that basically they already gave us the 12-year-old's heart rate. So the 12-year-old's heart rate is 70 beats per minute. Great. Now let's move on to the 2-year-old. We were using blue, so I'll go back to blue. And I'm going to write the unit rate formula, k equals y divided by x. And when I examine the two coordinates, I see that 3.5 and 315, those are smaller numbers than these numbers. So I'm going to choose this, thinking that this might be the easiest way to find the unit rate. So the y is 315, that goes in the numerator. And the x is 3.5, that goes in the denominator. And to find unit rate, we divide. That's a fraction bar. Fraction means division. So this is a complex fraction because it's a fraction that contains a fraction. So remember your complex fraction steps. Step 1 is to convert 315 to a fraction. So 315 as a fraction is 315 over 1. Then I convert 3.5 to a fraction. So I'm going to multiply 3 times 2, I get 6. Then I add the numerator 1, that gives me 7. And then the denominator stays the same. The denominator stays a 2. I'm going to go back to this blue color. Then you write the numerator first, so 315 over 1. Then you change the fraction division symbol to a regular division symbol. And then you write the denominator. So it's numerator, then the denominator second. Then we apply the keep, change, reciprocal method, or you could say the keep, change, flip method. And we keep this. The first fraction is locked in. You keep it 315 over 1. However, you make changes to this part. You change the division to multiplication, and you write the reciprocal of 7/2. The reciprocal of 7/2 is 2/7. That's supposed to be a 2. And then you just multiply across. So 315 times 2, well, 300 doubled is 600, 15 doubled is 30, so 630. And 1 times 7, we multiply the denominators and we get 7. And this works out very nicely because I can see right here, 63 divided by 7 is 9. So 630 divided by 7 is 90. So this would be 90 beats per minute. And let's label this. So the 90 beats per minute was for the 2-year-old. So the 2-year-old's heart rate was 90 beats per minute. Oops, not 909. 90 beats per minute. So now we're ready to answer the question. Rank the children from fastest heart rate to slowest heart rate. Then select the answer choice that lists the children in order from fastest to slowest. You have to pay attention here. A lot of the questions that you're being asked have been fastest to slowest, but sometimes they're going to say slowest to fastest or who's slower, so you have to read and be careful. We're going fastest to slowest. So let's just rank this ourselves first. So first would be, all right, the infants at 130. I think it'll be faster if I type. Then after that, all right, so the infant's 130, 70, and then 90. So the 90 would be next. So then we have the 2-year-old at, what was the 2-year-old's? 90 beats per minute. And then finally we have the 70 beats per minute, which is for the 12-year-old. And it was, 12-year-old we said was 70. 70 beats per minute. So it goes 130, 90, and 70. Fastest to slowest. I'm just checking my work. So it should be the infant, the 2-year-old, and the 12-year-old. So fastest to slowest, 12-year-old, then infant, no. 12-year-old, then 2-year-old, no. Infant, 2-year-old, 12-year-old. Good, that's what we said. So letter C should be the answer. Let's read D just to make sure. Remember, a good test taker reads every answer choice. Their heart rates are exactly the same. Well, that's definitely not true. So I've confirmed that the answer is letter C. Infants, 2-year-olds, then 12-year-olds from fastest to slowest.